Thank you. So this is me. Yeah, this is a photo that my previous colleagues do for me. So I think it's pretty funny. As well, I'm a graded human, or AKA, have a chip in my hand, like it's really common these days. So just to show some of my background, I was part of Arduino for the last 3 years in the research and development office in the south of Sweden. So we were doing a lot of IoT stuff and projects that they were never in the light, so in the spot was just researching and playing around with sensor and different kind of projects. So as well, I was, as a part of Arduino, I was organizing or helping to organize the European Maker Faire in Rome. So it's a really nice place to hardware companies, to makers that they have a cool project, because if you have really good to show, it's free for you. You get a free booth, and it's a lot of connection. And I think that's a really nice place to be, the Maker Faire. So as well, in the last 2 years, we were doing in the south of Sweden, in Skåne, a hackathon. It was an IoT hackathon where we tried to gather like up to 10 teams around the world, and during 48 hours, they were doing different projects and different ideas. So it's a lot of things going on in Sweden. And as well, I was collaborating with Biohacking in Malmo, doing some workshop and talking about implants, and as well in the first Biomaker conference. So I was helping with Arduino and doing nice workshop. So, it's pixelated, but yeah, it's fancy. This is the previous chip, the most common one that everyone has. Is a NTAG with almost 1 kilobyte of memory, unique ID. It's 2 times 12 millimeter, and of course the electronic is encapsulated in a Bioclass that is compatible, and is from a German company who has patents about the compatibility. Yeah. So we were doing, like in Malmo with the other biomakers, we were starting to make projects and for fun, trying to use the chip with different applications. So we did, Patrick, another biomaker, create the unlock for the computer. So with your chip and any Android, Arduino, or any other NFC reader, they could unlock the computer with the hand as well, with different other applications. But they started to discuss like what can be the next project, something fun. So we decided, okay, let's go to do a payment. So we start to think about let's go to use PayPal, let's go to use Visa, MasterCard, but you know we are hackers, so we decide, fuck it, let's go to Bitcoins. So we try to make a platform where using your chip, you can make actually a real transaction using Bitcoins. So the idea was you put your wallet in the chip, and we create a small, with a Raspberry Pi, we create a terminal that was compatible with this kind of technology. So the process was really easy, like just to create your Bitcoin wallet, write your data in the chip with any NFC phone, and you were ready to make payments. So we create this terminal. I don't know why the image is a little bad, but was a really like a prototype for a real terminal using Bitcoins that you just need to put the amount and press OK, and when it's ready, you put your hand in the right side, and it's when you make the transaction. We created this project with encryption, so if anyone could read your data or your chip, was encrypted with a public key in your typical private public key. So the encryption was more or less secure, even though, of course, it was a prototype, so you cannot prove and put all your safe in this project. But we released this open source, so a lot of people start to contact us and trying to expand this thing. Right now, there are some people in Brazil and in Latin America using this Bitcoins payment with chips. I don't know how it's going, but sometimes they write to me and they ask questions. So after that, I was continue thinking about what can I do, what can be the next step for make a project in biohacking community with hardware. So, of course, after create the terminal, Patrick, other guys, maybe Jovan and maybe Hannes, they were they were doing a workshop where in one day shop in Göteborg, people was getting for free implants and they could make payments using the implant inside of the shop. So it was free for everyone. During this event, one day event, we got almost 5,000 Swedish krona transaction using the Bitcoin project. 23 users got a chip, but inside of the 23 was like any kind of a profile, like woman up to 55-year-old and guys almost 20, 18. So it's any kind of demographic data, and was really interesting for us because it was almost 50% men and women. So it was really interesting for us when you saw this to the public, how they get attention, how they feel with different ways. Because, for example, the older person, I don't know, they have a special attraction with the idea of, I will never lose my keys because I have it in my hand. While the young people are more thinking in more integration with Twitter or Facebook. For example, I was doing some app where I was putting my Twitter account. So if I sweep my hand into your phone, you can follow me on Twitter or you can add me on Facebook. So this kind of bio apps was more up to youngsters, but the idea of don't lose keys was really in the upper age. So was a really success workshop. Actually, it was one day, but we really like it and enjoy it. So, like also was explaining, I was thinking what would be the next step, because I really like this biomaker idea and create hardware and create projects related with this integration between technology and the human. So I was in touch with OSA, and finally I applied for this program where I went to Shenzhen for 2 months. But you think 2 months is 2 months, but no, in China 2 months is like 1 year of intense. Maybe our friend can confirm, but was really intense the first weeks. I was like, oh my God, everything is so difficult, everything. I remember the first day I went to ask for where I can take money with the MasterCard. And people were like, what is MasterCard? So it's another word. So I understood you need to take your Bank of China. So the first weeks was really intense. But when you are in the loop of hardware manufacture and all the amazing technology you can manage there is amazing. I mean, it's I was completely agree with him. Like, you can make development per weeks. I mean, your hardware iteration can be 1 week easily. So it's amazing how fast you can develop project there for a low cost. So for me, it was a nice experience. And thanks to Maker Reason, I decided to create this project, Dsruptive, where I was trying to mix IoT with the Arduino idea, since I was working Arduino for a couple of years, and of course in terms of biohacking. Because right now there is not too many tools for people to create hardware that can be embedded in a Bioclass or embedded in any kind of implantable device. So having this idea and having the idea of try to integrate sensors inside of the body in a low-cost way, I decided to design a board like this in this size. So to have an idea of this board, it's like 1.7 times 3.6 millimeter. So it's really tiny. I have to use a microscope now to show it because it's really tiny. Of course, I was completely inspired by the first iteration, an NTAC implant. So I put the new chip there, where I have 2 kilobytes memory. So it's double memory than the first one. As well, it's a flex PCB, so it's flexible. You can shape it and put it in different part of the body. Plus, you have 2 layers of electronics. Now I will explain more in detail that. And as well as basic thinking in the Arduino way of be able to put shields, like in Arduino you have a board, and if you want to add a new functionality in this board, just you buy another shield and you put it on the top. So in this idea, I create this kind of pinout because, oh, it's really bad, the image, oh my God. No, so, but, well, we can use the microscope here. I will try to command tab. Yeah. So this right now is, how I can make this bigger? This. So right now, this is the bottom layer of the board, where you can see I put a LED because it's so easy to know in software that the first program that you wrote is the hello world, but in hardware, at least what I think the first test that you need to do is blinking LEDs, So if this blinking is working, so this is why I soldered there a 0.5 millimeter by 1 millimeter LED that reducing the energy from the NFC can enable the light. So it means this was the idea for have an implant where every time that you go to a door or every time that you use it, your hand is blinking, is feeling that it's, and as well I have 3 different colors, so you can put red, green, and blue, so you can customize your biohacker hand. So this is just the proof of concept because in this project I was trying to find a way to put electronic without battery because, after all this Samsung Note 7 and everything, I didn't want to go deep into that. So let's go to try to avoid use batteries. So I was thinking that the best way now is to harvest energy from outside. And since I have an NFC chip, so the idea is like I reuse the energy from the readers. So every time that you use in the gym on your phone or whatever is when you can feed the rest of the circuit. So this was my intention for this board. And just to give a sample of the kind of component I'm working, this is a temperature sensor, this tiny one that is just to, I don't know how to, so this is my finger, so you see it's really tiny. I don't know, maybe after you can pass by here and you can take a look because, so you will see how small it is. So for example, with this kind of board right now, you can design hardware where using NFC as a middleware, you can start to communicate electronic inside of your body in a cheap and easy way because in terms of development of the designing this board is almost the same as a normal one. The components are a little bit more expensive. So this is why with this project I was trying to enable to biohackers or makers to have a tool where they can start to design hardware to be implantable. And you were thinking how you can put this kind of board inside of my body. Like based on this Bioclass, it's so tiny. So it's based on this previous technology that they have. So you can imagine. Yeah, exactly. This is, so maybe someone can help me to put it while I'm talking because.
You bet.
Yeah.
What am I doing? Am I zooming or am I moving the thing that you're looking at?
Yeah, maybe I just want to show how big is the glass.
Okay, I messed it up.
Mm-hmm. So, yeah, but the glass is this one. Okay, this exactly. So this is the Bioclass that is 12 by 2 millimeters. So this board is completely compatible and fit into this glass. So you know that to make implant now, this is the easiest and the faster way to create it because you can put it there. It's biocompatible. They have patents. So as you can see, you have enough space to add any other components. So this was the project I was wanted to share with you. Oh, nice! Wow, I should ask you for help for the next assembly. Yeah. By the way, I was this board that have LED in this side, and I was doing the soldering by hand. So I did just 2 of 100 board I have, and I think I need to take a break because doing with the microscope, you have to be like a shooter. You need to breathe before you're going to touch it so it was quite hard to do it, but with emotion and with energy, I wanted to do it, and then you can manage to do it. So this is why as well, this Pinout, you can use a copper wire 0.1 millimeter to connect it. So still it's difficult, but it's make it easier to everyone to create their own PCB, so they can put bigger LEDs, or it's a matter of start to think how we can continue to create electronic in a cheaper way for implantable devices. So I will make a recap. Oh.
No, you're good. Yeah.
Oh? So, no, yeah, thank you. So this is more or less in my hand how it look. So you have the Bioclass that you can put it inside. Just you need an antenna, a coil antenna that as well I can provide it. The electronic inside, you can decide your own shield that I can, of course, it's open source, so I can share the schematics, so you can create your own designs. As well, the Bioclass I can give it. So I think it's a good starter to people who want to start to create hardware to be implantable or want to create new system. So this a little of the features that has. It's designed to be embedded in a biocompatible glass. This is the dimension we were talking. Have 2 kilobytes memory. So I think it's enough for all the data that you can save there. Now it's not that you cannot save a chapter of or episode of Mr. Robot, but maybe in the following month or year it will be possible. As well, have 50 years of memory retention. So I don't want to say, but I think it's enough for adult average. So hopefully in the following years not, but right now, you will have it. If you put it, you will have almost all your life, just so you don't need to change it or anything. As well, you have a possibility to add any LEDs, like it's just in the board to solder, or I can provide with the LED already, different colors, depend on your style. So, one of the more interesting feature for me is just I add the energy harvesting energy feature capabilities. So you don't need to use any kind of battery in the turn of feed component or have current. Actually, I make some tests. With this chip, you can get up to 2 volt, 5 milliamps. So for the hardware guys, it's enough to do some stuff. Of course, to sensor like temperature sensor or accelerometer, they are inside of these values. So it's quite interesting to start to make more stuff. Of course, it's NFC compatible and retrocompatible with the previous thing. So it's backward compatibility. So it's working with your favorite gym that you can log with your phone and everything. So in this term, is make it more universal in towards the actual system. And as well to share what is going on, this is the actual map that is today. I know some new thing happens with dangerous thing, like they're creating cryptography, but I think I'm going to the sensor IoT inside of the body. So as you can see, the NFC 1 kilobyte is the one I have already in my hand, that you get 1 kilobyte, but actually it's 888 byte. You cannot add any component, and the only interface is NFC. For example, you don't have harvesting energy. For the next revision that I will do with this board, I will add the I2C interface, so you can start to add real sensor there, even with programming. So this will be the next project. In this one was just LED and the possibility to reuse the energy from the NFC field. But like I say, is potentially you will be able to have I2C as well in this board. So just to give a small brief about what is going on here, just explain what is this board in 2 sentences. It's a small, because right now you don't have any easy tool to create hardware to be implantable in your body. You just can buy the already chip that you can implant, but if you want to play around, if you want to make your own implant with your own sensors or your own system, you don't have any tool. You need to design from the scratch. So instead of that, I was thinking to create the first board that you can start to work with to achieve what you want in an easy way. So this was more or less the core idea of this board. Right now I just make 100. I solder by hand 2, so. But it's going on. I mean, I'm thinking I can make it faster. And I don't know how we can, just to take an idea, I would like to, if someone is interested in take a look to see in real how is the size, I think I can show it with no problem. So yeah, this was the project. I guess is any question or anything? Yeah?